Hello, this is Retera, and today I thought, how about I try to teach programming in a way that's maybe a little different than how people would usually teach programming, but I think a sort of good starting point to try to teach someone. So in future videos, I'm thinking I might try to teach people Java. Java was invented long after the C programming language, which existed many years before it, at least to my knowledge. And the C programming language is sort of an important thing to see because it's where computers started and had a profound influence on languages like Java and other languages that people still use today, even if it's sort of infrequent that people would actually use C rather than C++, which is definitely still used for various modern projects. So what I've done today, you can see I'm on a Windows 10 computer, but I have remotely logged in to the server that handles etheller.com because this server is a Linux computer, and on most Linux and Mac computers, you will find that they come with a utility called GCC, the GNU C compiler, installed by default. So I'm trying to use this example because if you happen to have a Linux or a Mac computer, you might find that you could do what I'm going to be doing in this video without installing anything at all, just as sort of a usage of utilities that are already on your computer if you can figure out how to open a terminal, sort of like the one I have here. So in the world of 1970, when they started using these terminals, basically, it was very similar to Windows Explorer that you would use today, where you could scroll around and open various files and see what was inside various folders. But before they invented that, they always used a series of commands, right? They had come from the typewriter, and they had a bunch of people who were proficient with typewriters, and they were saying, well, where do I go with that to build a machine? So to that end, I'm going to use make dir, which makes a directory. I'm going to make a directory called programming lesson 1. We can go into this directory, and then I'm going to talk a little bit more about this terminal. So CD is equivalent basically to double-clicking the folder. It's basically that idea that you're going to change directory. That's what CD stands for, to go into that folder, right? So I'm going to go into this programming lesson 1 folder, and if I type ls in Linux or Mac, because they try to be like the Unix system where they try to have things conformant, that'll show what's inside the folder. So right now my folder is empty. Now if I were to create a file, you could see that file if I type ls. So let's create a file. We're going to use a thing called vim. Basically it's a text editor. It's like if I use Notepad and I'm going to make a file called test.txt, right? Inside this file, disregarding sort of the specifics of how to use Vim, you can edit a text file in any way that you want on your computer. I can put in this file, hi, this is a test, and I am a file. I hope you enjoy this video, right? And we can put that in the file. Here I'm going to use write quit, which writes the file to the hard drive and quits the program of Vim. But the details of Vim, which are not important aside, you can see that now when I type ls, we put a file inside this folder. So we're in this sort of ancient world of 1970. And because we're in this world, and you can typically open this on any Linux or Mac computer in today's time, we'll have the utility GCC, that GNU C compiler I talked about earlier. So to that end, let's make a basic C program just called test.c. We're going to edit it the very same way that we would edit a text file. You could use Notepad for that. You could use anything for that you like. I'm using Vim because it works really well when I'm remote controlling this Linux machine through Windows. So I'm going to open test.c right here, and I'm just going to type void main. Now main was invented in the C language as a standard that all programs would start with a function called main. I think even before C existed, they did that same concept with the assembly languages and the binary probably. I'm probably no use getting into that. It's not going to be very useful. But in general, to that end, when we see this void main function here, void is just saying that sort of like no type at all, right? It's like the function doesn't give anything back. So we're defining a basic function here, and we use curly braces to say what's the code that we're going to do inside of it. And what I think we want to try is something very basic. So put char is put a character, basically put a character into the terminal from which we're working. And we could just put a character like the letter G, and then if we save this file, you'll see that that is completely a valid C program that will just run. So if I use GCC, let me talk a little bit here about what I'm doing. In this system, GCC-O is output. So I'm saying we're going to output the program to the name test, and we're going to use as input the test.c as the code file. So it's going to read this code file. It's going to turn it into basically a binary program, and it's going to name that program test. If you were doing this on Windows, it would probably name it test.exe. However, GCC was not built for Windows, and in Linux they do not use the extension .exe. So as you can see, we have created a program test, and when I run it by typing /test and pushing enter, it prints out the letter G. It also prints this %sign. The %sign is just trying to tell me that I did not print out any new line carriage return at the end of that. And to give a better example of that, my code terminal that I'm using here, as you can see, has many fancy colors and various built-in things like that. If I type sh, I will go to an older world from before they had all the fancy colors and stuff like that. Now if I do the Control L, which I was doing to clear the screen before that, that no longer works. But if I run /test here, you can see it prints the G and then fails to go to another line and just continues on that same line. So that's what it was complaining about before when it put that goofy %sign. Now if I go back to where I was previously and I edit the code again, you can actually fix that by doing a put char and printing out \n, which is basically the carriage return, at least on Linux. And you can make a file called test, and now we can run test again, which prints out G and no longer prints that %sign. So if I was in that sh sort of older utility environment again, and I run test, you'll see that it prints out a G and then goes to another line. So that's kind of nice, right? We've made a very basic program that prints out G, but you might ask yourself, well, what if I wanted the program to print out the text hello to the world and sort of have a longer and more interesting piece of text, right? So if we go back to our code, test.c, C as a language had the idea of a character star. Now the star had a ridiculous special meaning that really slowed down a lot of people when I was in college in terms of really understanding what's going on in the computer. But it basically just means that the character star variable, instead of just being a character, is going to refer to a place where a character is, and as a result you can have multiple characters in a row in that place in the computer. That sounds complicated, but it's really not. So let's say I have character star called output words. That's going to be the name of the variable. So I have the type of the variable, I have the name of the variable, and we're going to say that output words is going to equal hello world, and then another one of those carriage returns. Now, what's nice about that, in fact, actually, we probably don't even need that carriage return in there because we already have it at the end of our program. In the C language, similar to a lot of others, you can use 2 // to make a comment. So we can leave a note for ourselves that won't affect the code that says, this prints the carriage return. Just right there at the end of the program. Now what we're going to do, because we have this output words here, is let's make a little loop that's just going to loop through the various output words and put them on the screen with that put char function, right? So what you want to do, if you want to do that, is just say, we'll have an integer, like a number, right? And we're going to have a number that's going to be the position in these letters that we're currently looking at. So I'm going to have the number called character index. It's the index of the character in the word that I'm printing. And then I can say, while character index is less than, and now you think, I need a way to know, how do I know the length of the text hello world? Well, C actually had a function for that called strlen. So I can say the string length, strlen of output words, and I can say while the character index is less than the length of the output words string, we'll just have that computer increase the character index. So we're going to set character index equal to character index plus 1. We're just going to assign it its own value increased by 1. So we're going to step forward through hello world, and as we do, we are going to print out the character. Now you might be wondering, well, how can I get one of the letters from output words? For C, in any sort of array like that, what they typically do are the brackets. So I can do a bracket here and say character index. And that then says we're going to print out the character at that location in the output words. So it'll say character index is 0, so it'll have the 0th character, the H. It'll put char that, and then I'll say character index equals character index plus 1. So it'll assign from 0, now it'll be plus 1, it'll be the E. And it'll print the E. And if all of this works correctly, when we're done, we'll have a program that when we run it, prints out the text, hello world. So, without further ado, let's try it. GCC. Turns out it's complaining about several issues. So this is where, if we look, says implicit declaration of sterling. While character index is less than sterling. It's pretty mad about that. So we'll check that out, but that's just a warning. The errors here typically mean things that will stop us from building the program. So I put output word instead of output words. Everyone makes mistakes, and that's how you find them. The computer will just sort of tell you there. So output word now is output words. And now what that means is that hopefully the program will be fixed. It also says I'm missing a semicolon. That's a little bit silly. Let's put that semicolon right there. So now we're going to make a test program. We're going to build it out of test.c. It's still complaining because I'm using the function strlen for managing the length of a string without loading it from a library. Now, if you actually wanted to load from a library, there are a large number of libraries, and you can just use a # include as sort of a library load in C. That gets into a bunch of more complexities that we probably don't want to worry about too much, but suffice it to say that there's a library called string.h for handling strings of characters. In that library, there's a function called strlen, which is the string length function that will tell me the length of hello world. So by including string.h, we remove that error from our code. Now if I do test.c, it no longer complains about anything. And let's make it pretty. Let's put it at the top here, /test. It prints out hello world. So that's an example of within the C language where the only library functions we used were put char to put a character out to the text terminal, and string length to find the length of a string, which we got from the library. That example then is an example of the basics of C, and basically really what people had in their mind when they created the language of Java. Some of these other languages like Java that are tended to be preferred as a first language to teach people have a bunch of higher level concepts like public and static and private and these other things that were invented long after C, because C made it very difficult for large numbers of people to work together. It's very easy if you just have functions like this, right? Void main and whatever other functions you could write, that you might call a function someone else didn't want you to call. And so they started building all these additional concepts and additional concepts on it to make it basically try to make it simpler, but also at the same time making it more complicated. So that's the interesting thing. If you go back to sort of 1970 with the C language like this, right, and you think about where did it all come from, I think it helps to sort of see that picture and to see what programming was like in the past for the people who built programming in how it is today. So I hope you've learned something from our video today. And if you're interested to try this yourself, again, if you find a terminal or terminal emulator on a Mac or Linux computer, you should be able to do exactly what we've done here today, hopefully without installing anything. So I hope you have a good day, and I hope you have learned something and had some fun.